Malaysians, this is how Malaysia fight them. For anywhere where there are several cases, all businesses were closed, roads all blocked, no one in or out, no one could leave their homes. But don't worry, food and medical care were provided and Malaysia case number they start to drop. People start working with the new normal, which implements specific SOP in every places. For those who suspected, samples were taken. Here I will show you how the sample is tested. COVID-19 testing usually begins with a swab of the nose or throat. Saliva, mucus or fluid from a patient's lung can also be used. There are 4 methods that are available for detection of the virus COVID-19. The first one is known as reverse transcript polymerase chain reaction (RT-PCR). The second one is known as loop-mediated isothermal amplification, or known as LAM. The third one is lateral flow assay, and the final one is enzyme-linked immunoadsorbent assay, or known as ELISA. The most reliable and expensive method is the RT-PCR. It also took the longest time for detection. The LAM and ELISA can be done in a batch up to 90 samples. However, the sample detection also longer and possible for error. LFA is the fastest detection. However, it can only detect the immunoglobulin, which means after the patient has been infected and shows symptoms. I will explain to you how the graphene FET detection for virus COVID-19. The virus is contained in the blood sample. The blood will be dropped on the graphene FET. The virus spike protein will attach at the binding site of the antivirus protein, which immobilizes on the graphene surface. Graphene will be served as the conducting channel. The reaction is observed based on the drain current step in antibody conjugation. Why graphene is chosen? Graphene is a 2-dimensional material. It's made of carbon atom arranged in a plane only 1 atom thick. If the graphene were thick as a piece of paper will be as thick as a 2-story building. So how do we get to make such a material? Everything starts with a graphite. Yes, graphite, as in your pencil. If we zoom in, we would see a bunch of graphene layers stuck together. We just need to exfoliate them. In each layer, the atoms are very tightly bonded, but the layers are weakly bonded among them, so we can just exfoliate them. Tear some of these layers apart. Using this method, the scientists managed to get the first 2-dimensional material ever, but the samples appear randomly distributed with uneven shape and size. This is not a natural way to make graphene. The chemical way. Chemistry came along to help with the fabrication process. The chemical vapor deposition method is a procedure that literally achieves the growth of thin film of graphene. For the case of graphene, it starts with a wafer of copper. Then it immersed in the methane CH4 and heat to really high temperature. The metal molecule consists of single carbon atoms surrounded by 4 hydrogen atoms. When the molecule of CH4 hits the copper, the carbon atom gets trapped while the remaining hydrogen atom keep moving. This effectively creates a layer of carbon atoms that can be several centimeters long. But the carbon is too tightly bonded to the copper, so it's difficult to do anything with it. To transfer the graphene around, it is physically covered with an organic polymer PMMA that acts as a protective layer using a technique called spin coating. Then the copper wafer is deposited on acid that dissolves the copper but does nothing to the graphene until all the copper have been removed. Finally, the graphene PMMA is washed with water to remove any residue from the acid. It is then picked from the water with another wafer, usually made out of silicon oxide. When the graphene is ready to be used in a device on an experiment, the PMMA is removed using acetone or other solvent. And this is how we get to obtain a two-dimensional material. To fabricate the FET, the substrate is applied with a photoresist. A positive mask is applied on top of the photoresist. After undergo photolithography, the photoresist is etched and a metal contact is deposited by using lift-off method. To deposit the graphene at the channel, a photoresist is applied onto the electrode. A positive mask is applied on top of the photoresist. After doing the photolithography, the graphene is deposited on top of the photoresist and then will be etched followed with the graphene on top of it, leaving the graphene alone on the channel surface. To understand the effectiveness of the sensor, the performance comparison is observed based on the limit of detection. The choice of material and the design of the graphene plus a smaller area of the channel contribute to lower LOD. This is mainly because of the higher transconductance. Based on Campos et al. 2019, they are able to achieve down to 25 attomole limit of detection with a single layer graphene at the channel and a smaller channel size. Early detection of disease has become an important method in providing precision medical and better medical assistance. The following are a few examples of critical disease and proven biomarker recognition. The detection for COVID-19 virus is the spike protein. For detection of cancer is the DNA mutation. Acute myocardial infarction is for cardiovascular disease. That's all for me. Thank you. Bye-bye.